Assalamualaikum and hello everyone. In this video, we're going to discuss week 1 hour 3 tutorial for both NFTF and also FTF questions. As for NFTF, the learning objective states that you should be able to perform calculations using integrated rate equations. As in our previous tutorial, we already learned about this integrated rate law. So for 0th, 1st and 2nd order, you need to know how are you going to get the integrated rate equations. Alright, so let's start doing these first questions. The following reactions gives you NO in gaseous states react with half of the Br2 gaseous states to form NOBr gas. So these reactions is second order in nitrogen oxide. So it states here only for NO there are second order, and while for bromine there are first order. So the overall order of reactions is 3. Another information given here is the rate of reactions, which is 1.6 10 to the power of negative 8 mole per liter per minute when the nitrogen oxide concentrations is 0.020. Means we got another information here, which is concentrations of nitrogen oxide. Okay, 0.020 molar. And then we are also given about Br2. Br2 concentrations of 0.030 molar. And then the first questions ask you to calculate the value of K. So how could we calculate this K? K is the rate constant. So where can you find K? Can we find K in rate of reactions formula? Nope. Can we find it in differential rate equations? Also nope. And then can we find it from rate law? Yes, we can. So the rate law is a relationship between rate is equal to rate constant to the concentrations raised to some powers. So now we have reactants of NO and also Br2. Then we need to write the rate law. So now our rate law starts with rate is equal to K concentrations of NO. So we know that our NO is in second order, so we must put second 2 here, sorry. So 2, and then we got another concentrations of Br2. Okay, and this is first order reactions. Some of you might ask, should we put the 1/2 coefficients in the concentrations here? Nope, this 1/2 right here is only for balancing the equations. Okay, so in our rate law, we didn't take any coefficients together. We take only the species, the Br2. Alright, so you want to find K. So now do you have all the informations other than K? Yep, we already have the rate of reactions, we already have the concentrations of NO and also concentrations of Br. So simply rearrange this rate law, then you're gonna get K is equal to rate over concentrations. So our rate is 1.6 10 to the power of negative 8, right, divided by, so our concentrations for NO is 0.020, so 0.020 raised to the power of 2 times with, we have bromine of 0.030. And as for bromine, we only have first order reactions. When you insert this value into the calculator, then we're gonna get value of 1.333 10 to the power of negative 3. So do we have any unit for rate constants? Yeah, we should have one. So how do we know the units? Now we need to do it one by one, since the overall order of reactions is third order, so we need to do it manually. So we know that our K, we have mole per liter per minute. Okay, this is for our nominator. And then we go to our 0.020. So initially we have mole per liter, but then we have the power of 2. It means that we need to have mole. So mole will become mole squared. Per liter will become per liter squared. And then we have another concentrations here, which is mole per liter. So by right, the denominator will cancel out the numerator if they got the same units. So since we have mole per liter here, we can simply cancel out them. And then leaving you only with this. So mole squared per liter squared, we're going to take it to the higher, to the denominator. So it will become mole negative 2 liter to the power of 2, and then per minute remain as it is, remain unchanged. So this is gonna be our final unit for this reaction, since it's got overall order of fractions of 3. Okay, so next questions we will ask if the rate of reactions is 3.5 10 to the power of negative 7 mole per liter per minute, and concentrations of NO is 0.043, we need to calculate the concentrations of bromine. So by using the same rate law as in previous questions, this one, okay, so this rate law, we're going to use it again, but this time around we need to change the rate of reactions and also the concentrations of NO, and we can use our rate constant here, 1.333 10 to the power of negative 3. So now we rearrange the rate law and make the Br2 concentrations to be on the left hand side. So we're gonna magnify this a bit. So we're gonna have Br2 on the left hand side. Okay, Br2, we know that it is raised to the power of 1. Okay, so then we're gonna have rate over rate constant concentrations of NO raised to the power of 2. Okay, once we substitute the value, okay, our rate is gonna be 3.5 10 to the power of negative 7, then divide with 1.333 10 to the power of negative 3, and our NO concentrations is 0.043. 0.043 molar, and then we have squared, don't forget your square. Lastly, we're going to get concentrations of Br2, which is 0.142 molar. Okay, right. So finish with the question B and then proceed with question C. Again, we are given the rate of reactions, which is 2 10 to the power of negative 6 mole per liter per minute. But this time around, we are given Br2 concentrations, which is 1/4 NO. So now we want to determine the concentrations of nitrogen oxide. This time around, the concentrations given is not in terms of molarity, it's not in terms of the value, but they give some substitution to be made on the rate law. So again, we need to rewrite the rate law. So we know our rate law gonna be rate is equal to KNO squared concentrations of Br2. So now we want to find the NO. And for Br2, we need to change it with 1/4 NO. So simply replace the Br2. So we're going to have rate equal to K N squared. And then as for this Br2, we're going to change it to 1/4 Br2. 1/4 NO. We need to replace only the Br2 with NO, not the whole thing as for NO. So we need to remain the order of fractions as only 1. And then we simply substitute the value. So we already have the rates. We have this rate. We also have the value of K. Right? So lastly, we're going to get concentrations of NO of 0.182 molar. Okay. I didn't do the substitutions because you simply substitute the value and then you rearrange them so that the NO will be on one side, and as for the others, we put it on the other side. Okay, so this is going to be your final answer. Okay, so let's look at the question number 2. Given to you iodine atoms combine to form molecular iodine in the gas phase. So you initially have I in gas state and also I in gas states to form I2 gases. Alright, so the rate constants for the above reactions is 7 times 10 to the power of 9 per molar per second at 23 degrees Celsius. Alright, so for these questions, do they give you any information regarding the order of reactions? Do they say this I got order of fractions of 1, this I got order of fractions of 1, so there are 2? No. So the hint given here is only the unit from rate constants. So if you look here, you have rate constant with unit of per molar per second. We already discussed about this in previous tutorial where per molar per seconds belong to second order reactions. Okay, how do you know this? You need to memorize them. One of the way to know this is by memorizing, or maybe you can do it from scratch by combining the rate of reactions and also the rate law. Then you can get the unit of reactions, unit of the rate constants. Okay, so we know that this is a second order reactions, and then we'll proceed with these questions. If the initial concentrations of iodine atoms is 0.086 molar, so given to you 0.086 molar is the initial concentration, so we put it as concentrations not, right? So calculate the concentrations. So we want to calculate another concentrations here, but only after 2 minutes. So this 2 minutes belongs to time, and this concentrations is after this time, which in this case 2 minutes. So we have T here. So we know that we need to find concentrations of iodine at certain time, and then we have informations regarding initial concentrations and also the time taken, and we also have informations regarding rate constants. So how do we start doing these questions? Okay, for such informations, we're gonna use integrated rate law for second order reactions. So the integrated rate law for second order reactions is 1/, concentrations of iodine at certain time equal to 1/, concentrations of iodine at initial states plus with KT. Okay, so we want to find the concentrations of iodine at certain time. We already have informations regarding concentrations of iodine at initial state, we have the rate constants value, and also we have the time taken here. But please bear in mind that the time taken given is in minutes, but then the rate constants given is in seconds. So we need to change this 2 minutes to second. We keep the value here, so 1 over iodine at certain time equal to, so 1 over initial concentrations is 0.086, so we write as 0.086, and then we have plus this value with the rate constant, so our rate constant is going to be 7 10 to the power of 9, and then we have our time. So time, we should change the time from minute to second, so we have 2 minutes here, and for every 1 minute is equivalent to 60 seconds. Okay, so we simply times it with 2, and then once we calculate this in our calculator, then we're gonna get concentrations of I after 2 minutes, so 2 minutes our T lah, is equal to 1.19 times 10 to the power of negative 12 molar. Okay, don't forget the unit because concentrations got its unit. Alright, so we're done with these questions. Proceed with the next one. Calculate the half-life of iodine atoms if the initial concentrations is. So these questions ask you to calculate the half-life. So this is a totally new thing for this tutorial, but we have already learned this in our lecture. So half-life, so since we know that this overall order of fractions is second order, so means we can simply use the half-life formula for second order reactions. So for second order reactions, our half-life formula gonna be half-life is equal to 1 over K concentrations of, so here we have concentrations of iodine. Right. So we already have our initial concentrations. So our initial concentrations here is 0.42. So simply substitute the value. So 1 over K. So our K just now is 7 10 to the power of 9. So we have 7 10 to the power of 9 times with, so we have another concentrations here, 0.42 molar. Okay, lastly, we're gonna get our half-life should be in second, so we're gonna get 3.4 10 to the power of negative 10 second. Alright, so same goes to the final questions here, 0.6. So simply use the same formula. So I will simply substitute the values. So our T half gonna be 1 over 7 10 to the power of 9 times with 0.60 molar. Lastly, the half-life will be 2.4 10 to the power of negative 10 second. Okay, that's it for our non-face-to-face questions. Let's proceed with face-to-face questions. At the end of the lesson, students should be able to determine the order of reactions of reactant using initial rate method. So let's recall again, there are three methods to determine order of reactions. Since we know already, order of reactions can only be determined via experiment. So if we say experiment, means we need data, a number of data. Okay, now the questions already ask you to use initial rate method. So initial rate method is the only way that you don't need to use graph, okay, in determining the order of reactions. Okay, the data below were obtained from the following reactions at 27 degrees Celsius, given the reactants on the left hand side and also product on the right hand side. Also, there are a number of experimental data given, and please note here that the data given is only for reactants. Okay, and also given to you the reactions rate, where the unit is in molar per minute. Okay, the questions ask you to determine the order with respect to each reactant. So recall again, where did you first heard about order of reactions? It is from rate law. So we need to write the rate law for these reactions, where rate is equal to rate constant, concentrations of CH3, CH, and we have our halogen in here, also CH3, raised to the power of, so we need to put unknown here, let's say we put it as M. Right, you are free to choose whether you want to put A or B or X or Y, whatever it is, as long as they are unknown. And then followed by another reactant of sodium hydroxide, raised to the power of N. Okay, so you need to find the order with respect to each reactant. So in order for you to find the order for each reactant, you must make one of them as constants. So if let's say you want to find the order for the first reactant, which is M, you need to take the concentrations of sodium hydroxide, which has the constant value. So for this initial rate method, we need to compare between two experiments. So in order for you to do that, since we want to find the order for M, then we need to look at concentrations of sodium hydroxide that has constant value. So if we look here, if we check at the table, we can see the first experiment and also the third experiment got constant value of sodium hydroxide. So we can compare these two experiments, and then usually we will put the bigger value on the upper parts, which is the numerator, and the low value as the denominator. Alright, so let's try to substitute this value into the rate law. So we're going to compare rate 3 and also rate 1. Okay, so we're going to write it as rate 3 over rate 1. Okay, so we're going to substitute everything in here. So we'll write K CH3 CH Cl CH3. Okay, and then we have K, the same thing here. So I guess I should just use this lasso thingy so that I can just copy them and also just paste it here. Okay. So we have another one here is sodium hydroxide. And also sodium hydroxide. This one to the power of N. So this is M, M, and also N. Usually we write as, this is for experiment 3. This is for experiment 1. This is for experiment 3. This is for experiment 1. It's just indicating that this belongs to which experiment. So we could see that the sodium hydroxide got constant value. So we can simply cancel these values since they are constant. And together with the K, so we can also cancel out this value, leaving only rate of experiment 3 and also rate of experiment 1 together with the concentrations of the first reactants here, because we got different value. Okay, so we're going to take this and then substitute into the formula. So our rate 3 is 9 10 to the power of negative 3 and rate 1 is 3 10 to the power of negative 3. So simply substitute the value 9 10 power of negative 3 divided 3 10 to the power of negative 3, and then our concentrations here is 0.45 over 0.15, 0.45 over 0.15, and don't forget your order of reactions, which is M. Okay, once we put this value into the calculator, then we're gonna get 3 to the power of 1 is equal to 3 to the power of M. Okay, and then lastly we're gonna get M is equal to 1. So we could say that so this is the order of reactions, so the order of reactions for CH3, CH, Cl, CH3 is 1. Okay, so we got M is equal to 1, so the order of reaction is 1 for M. Okay, we're going to use the same method, so the same procedure in finding the order of reactions for sodium hydroxide. So we're going to put another divider here, so we could find for this one. So look at the constant value at the first concentrations. Okay, so we have 0.15 on both experiment 1 and also experiment 2. Okay, and then we look at the higher value of reactions rate. So experiment 2 got bigger value, so we put it as denominator. So we're going to compare between rate 2 and also rate 1. Now we're going to write it as, can we simply take this? Okay, I'm going to use my power to copy everything in here so that we don't need to spend so much time on this. Okay, I'm going to copy this and I'll put it here. Wait, here. Oh my god. Okay, tak apa. Paste. And we're going to bring it over here. Slowly but surely. Okay, now, and then we simply change the numbers. So since we are going to compare experiment 2 and experiment 1, so we simply change it to rate 2 over rate 1. And here, Allah. Okay, and here we gonna clear these things. Okay, right. Okay, right. Okay, sorry. 1. So this is 1. This is N. This is N. And this is 2. For this one is 2. Okay, since we want to use the constant value for the first reactant, so we're going to cancel this out, leaving only the rate of reactions and also the concentrations for sodium hydroxide. So we know the value here is 6. Okay, so we have 6 10 to the power of negative 3 divided by 3 to the power of negative 3 equal to, so we have the concentrations of sodium hydroxide for experiment 2 is 0.50 divided by 0.25, and don't forget the order of reactions here, our unknown, which is N. Okay, once we calculate this value, we're gonna get 2 to the power of 1 equal to 2 to the power of N. So simply factorize it, so you're gonna get N is equal to 1. So we know that the order of reactions for sodium hydroxide is also 1. So we need to write the conclusions where the order of reactions of sodium hydroxide is 1. Okay, so sometimes we need to tell that the overall order of reactions. So the overall order of reactions for this reaction is 1 plus 1 is 2. But since the questions didn't ask for that, so we can keep it as it is, keep it separately. But if the questions ever ask you about the overall order of reactions, you simply add these two values. Okay, so next one, we need to write the rate equations. Rate equations, in other words, the rate law. So our rate law here, we cannot use the rate law with unknown order of reactions. We need to apply the value that we have already calculate for M and also N. So we know already the order of reactions for both reactant is 1. So simply rewrite your rate law, but this time around together with the order of reactions. So we're gonna have rate law of rate is equal to K concentrations of two chloropropane. So we have CH3, CH, Cl, again another CH3 to the power of 1. You can write 1 or you can leave it as it is because it's already symbolizes that this is order of reactions 1. And then we have sodium hydroxide. Okay, so do we have any other questions for face-to-face? Yay, we're done with this tutorial. So we're gonna proceed with the week 2 hour 1 tutorial, which will cover on initial rate method and also another 2 ways to determine order of reaction, which are linear graph and also half-life graph. Alright, so I guess that's all for today. Thank you everyone. Assalamualaikum.